Everything's nice with AI until it makes a mistake that a human would never make, ever. And this reveals that it wasn't actually smart. You can really eliminate hallucinations, and they happen when you least expect them. It happened to Air Canada that the chatbot gave the wrong policy to a customer, and then Air Canada had to honor the policy because the judge told it to.
Emmanuel Maggiori is AI industry insider who has developed AI for a variety of applications. He is the author of the books Smart Until It's Dumb, Siliconed, and the AI Pocketbook.
The book, you mentioned about 2 AI booms that happened, but actually it ended up going nowhere in the end. So maybe tell us a little bit of this history.
There was an AI boom in the 60s. Everybody will lose their jobs in 20 years. That was said in the 60s. Then in the 80s, another boom, another collapse.
There are concerns. What will happen to my job? Especially for tech software engineers, many can be replaced, including juniors. What is your opinion about?
There will be jobs that will be lost to AI for sure. Maybe prematurely sometimes. We've already seen companies firing people and now hiring them back because it didn't work.
Businesses scrambling so hard to adopt AI. How can business start thinking about adopting AI?
Building a successful business is a business problem. It's not a technology problem. I've seen so many projects fail almost the same way every time. The best way to use AI is to acknowledge these hallucinations from the get-go. If you embed that into your product, you can build a successful product. When they tell you AGI is coming, right? I would tell you the answer is no. So AGI is not coming anytime soon. And the reason is that
Hello everyone, welcome back to another new episode of the Tech Journal podcast. Today I have with me someone very excited to, share some learnings or some insights that he has been dealing with regarding AI. I know maybe this is like on everyone's mind these days, right? Emmanuel Maggiori actually wrote 2 books related to AI. The first one is called Smart Until It's Dumb, and the second book is titled The AI Pocketbook. I find this a rare opportunity for us to learn more about AI, what actually these days, generative AI, LLM, all these tools that we have been hearing a lot and using a lot in our day-to-day work, try to understand the basics and maybe few interesting things that Emmanuel can share today for us to learn from him. So Emmanuel, thank you so much for this opportunity. Welcome to the show.
thank you for having me.
Right. Emmanuel, I always love to invite my guests first to maybe share a little bit more about you by sharing any career turning points that you think we can learn from you.
Career turning points. Yeah. I think there were 2 important ones. The first one was when I realized that a lot of the technology industry was driven by hype. A lot of projects were just, I don't want to say fake, but a little bit fake. Sometimes not on purpose, but you find yourself working on products or on building products that don't make any sense, and everybody knows it, right? There's a difference between an experiment that is worth doing, right? Okay, we don't know how the client will react to this, so we're still going to build it as a sort of MVP. There's a difference between, that and just building something that doesn't make any sense. Everybody knows it, but you're still building it because a VC told you that it was a good idea, or because an upper manager from a company just gave you a lot of money to do this, and then you're just doing it. And unfortunately, I found myself involved in projects like that a little too much. And at one point I thought, it seems like most of it, especially when you work on cutting edge stuff, is like that. And I think it was a turning point because I was very naive before, right? I thought companies are efficient. Why would a company ever carry out a project this long when it's obvious that it will never work? But, they do. Things like that can last for a very long time. And these projects, they get swept under the rug very easily. So I think that was an important career turning point. And I think another one, which, that first career turning point led me to the book Smart Until It's Dumb, what you mentioned, right? It was, I need to tell the world that AI is not that great, that there are lots of problems with it, that lots of projects fail, and why. So that was why I wrote that book, right? And then another turning point was, I thought I'm going to work on more foundational stuff, less hyped up stuff, just do some more traditional software engineering. But then I realized that a lot of people weren't working much. They weren't doing anything. right? Including me. I found it hard to find work to do. I was hired by a company. I thought it was going to be super exciting, and they kind of put me in this staging area to wait until I was assigned to a project. And there were lots of us in there being paid to do nothing, right? And that, I thought something's really strange with this field. Seems like there's a lot of money flowing into the field, lots of projects, they get launched without really knowing what, they're going to be or what we're going to do. And companies like to hoard staff sometimes. And I thought, again, this is companies not being very efficient, and I didn't think it would last. And then everybody got fired, right? Twitter fired 80% of its employees, and everybody, Meta, all major companies made a lot of people redundant. And I thought, some people work very hard, but a lot of people, they just don't know what to do. And I thought that wasn't sustainable. So that was another learning for me.
Wow, very interesting sharing that you just shared just now, right? So when you said that, I also had experience of those kind of, projects, career, right? Where, seems things are going to the wrong direction, but we still march on anyway. We think that something positive will come out of it. And the second one, especially for consulting or professional service kind of work, sometimes, we were put on the bench or on the beach, some people also call it. And maybe in some big organizations, there are roles which have maybe little things to do and, spend their time doing, something else, which is not necessarily productive. So thanks for sharing that personal journey that you have so far. And I know the books that you've written is something about AI, right? So probably you can share a little bit of background why you wrote those two books, like what kind of things that you actually want to convey by writing these two books.
So I think my first book came out of this frustration of everybody saying that AI was the future. We should be AI first companies. And this was, look, I wrote the book before the ChatGPT thing happened, but ChatGPT was released when I was finishing the book. So I added stuff about it, but it was kind of about that time. But what I'm trying to tell you is that I've been noticing this before even that wave of AI hype that we witnessed. And I wanted to tell people how AI actually worked, how machine learning works and why it has some issues, let's say. There were lots of, it was a very broad book. I even spoke about consciousness or the mind, because you have all these people even telling you that we're just building artificial neurons. But in reality, we don't really even know how neurons work very well. So how can we actually be building them? So I thought it's good PR, but it wasn't quite true. And I wanted to also convey, if you want, my experience in the business of AI, because I've seen so many projects fail that I identified a way in which they fail almost the same way every time, repeatedly, the same mistakes. And I thought I need to tell this to the world. Right? So it's a kind of an antidote to AI hype. That was the goal of my book.
Right. So yeah, I remember back then, I don't know, like 5-10 years ago, right? So there are other fields of AI compared to what we know now, which is like generative AI, LLM, all the craze about these kind of AI. But in the past, there are so many AI technologies as well. And in fact, in your book, you mentioned about 2 AI booms that actually happened, but actually it ended up going nowhere in the end. So maybe tell us a little bit of this history so that people know about the context and they can relate to what they're experiencing now.
Yeah. So there was an AI boom in the 60s, which is kind of crazy because computers were new, right? And they weren't very powerful. But people were saying all these things. Everybody will lose their jobs in 20 years. This is something that was said in the 60s. And there was a whole boom around AI. The idea was to build those sort of artificial worlds, right? You could have a world where you simulated some physical things on a computer, and people thought that would have an impact that it didn't, right? In the business world. So after that, there was what's known as an AI winter, which means a time where there was very little money in AI and very little enthusiasm about AI. Then in the 80s, there was another boom, right? And millions invested. And this was about expert systems, which is when you try to encode all the knowledge of a person as rules inside a computer. It didn't work well. It was impractical to do. And there was another collapse, if you want, of the AI field, another bust of the bubble. It also became almost shameful to say that you worked in the AI field at that point, right? People said, stopped saying AI. They started saying I work in cognitive something because they didn't really want to say AI because it was stigmatized. Then we had, after that period of, let's say, kind of calmness, there was a much more moderate, if you want, boom of AI that started to happen in the 2000s. In 2010, it intensified, right? And that's the one that kind of I lived through. There was a difference here, though, which is that AI in the form of machine learning. So this was the machine learning boom, right? The computer learns how to do stuff from data. And the difference is that this time AI is successfully used in commercial applications for the first time, right? You have your Netflix recommendations, and there's AI there because the computer's learning from your behavior and also what other users that are similar to you like, and then you get personalized recommendations. AI will sort search results when you're shopping for a holiday, when you're searching for things on Google. So AI has been with us for a while, and it's been used in a commercially successful way, right? And that's when I thought people were exaggerating about the power of AI already, because they were saying we need to use it for absolutely everything, right? And then ChatGPT happened. So that's kind of a new wave. Yeah. Yeah, I thought there was going to be a sort of AI winter again before ChatGPT, and there were signs of it. There were some industries that were struggling, especially the self-driving car industry, for example, that was doing really, really badly and still is. But then with ChatGPT, everyone forgot about that, and it was like the most impressive boom that we could ever imagine. Yeah.
Yeah, so I think I feel that, all this hype about ML, I experienced it maybe back then, 2010, 2015, those kind of era where you start having like, I don't know, vision, OCR, those kind of things. Recommendation system also starts to appear. And then maybe a few cloud computing also productize their AI services, right? So I think that's when some of the craze about AI, people are trying to use that, especially also a lot of startups, cool disruptors, so to speak, right? They want to also implement AI use cases. And I think, yeah, this time is really so much different, the ChatGPT, the generative AI era. So what do you think makes it such a craze now? Because, you have studied the history before, but this time it seems so real and so different. And people are even talking about AGI and all that stuff.
I think there are a number of things. So the first one is that this new generation of AI is used by the general public directly. Just go into ChatGPT and use it. Because the previous generation wasn't like that. As I said, there's AI recommending you movies on Netflix, but you don't get to see any of that. You don't use it yourself. But now with ChatGPT, you are using it directly. So people have access to AI in a much more straightforward way. But also, it's conversational AI. And that's a big difference too. And there's so much fascination around having a conversation with a machine. And it's also one of the most difficult tasks historically. The Turing test is that. It's like, can you build an AI that is so powerful that you can't tell whether it's a human or not? And this test is a conversation where you chat with an AI, right? So conversation is fascinating and it has so many applications. And I think that's also a crucial difference with previous generation of AI.
Yeah. And I find the barrier for you to use it is so much easier now, right? So you can just go to a website or even embed it in your phone these days, right? And even you can speak to it the assistant way, just like what you mentioned, right? I think so many people just try and they believe it's pretty smart. Your book is titled Smart, but it's dumb. So why do you call it so? I guess that's the first thing about AI, right? Because people think it's smart, but actually, maybe there's another side to it that we don't know.
I think that was pretty much the thesis of my book, which is that AI works really nicely and it's impressive until it's not, because you discover, I called it at that time an epic mistake. Now it's called a hallucination, right? That's the name that people have adopted for it. But I've been warning people about this for a very long time, which is that everything's nice with the AI until it makes a mistake that a human would never make, ever. And this reveals that it wasn't actually smart, right? And those things, again, they're very difficult to quantify and to even, define. But intuitively, all of a sudden you're like, okay, this is really, really dumb. And I've been observing this for a long time. And I thought this was, for example, the thing that would kill the self-driving car industry. And it is the thing that did kill it's almost dead. Like Cruise cars, the brand Cruise that builds self-driving cars, they have more people in a control room than self-driving cars. And they operate them remotely. They don't really operate, they react to problems, right? And they happen so often they need more people than cars, right? The other company, Waymo, they also have a control room and they intervene every 3 to 5 miles of driving manually, right? And I knew this was going to happen. I've been saying it for years. And the problem is that machine learning learns by repetition, learns by example, right? So you need to show examples of situations, and then the computer kind of interpolates. If it's seen two similar examples and there's something in between, it can make deductions, but it's not very good at processing situations that are far from anything the computer has had access to, the data. And when you're driving, there's so many things that could happen that are completely out of the ordinary. And for some reason that we don't really understand, humans are very good at that. We seem to have these internalized models of the world that we use to process things, to analyze things that, you see something totally different you've never seen, but you know how to react to it. And with machine learning, it's notoriously bad at that, right? And I said this is going to be bad for the self-driving car industry. And that's what's been making the adoption of AI so hard now, even now, generative AI in the enterprise world, right? Or even to code in a serious way. People say, oh, it does 80% of the job, but then I have to go and debug the thing that AI created, and it's causing me more trouble than if I'd done it myself. Not always, but there's and it's again these hallucinations, and that's why I thought smart until it's dumb is a good way to summarize this, right? Kind of describes the whole situation in a very short sentence.
Yeah. Yeah, I think almost everyone, including software engineers, right? I mean, I perceive us as someone who understands how a computer works, and maybe we know about logical thinking and things like that. Even us are still kind of like impressed sometimes when you use coding assistants. How come it can generate a code that seems to work? I mean, it works. There's a vibe coding as well, right? These days, it seems to work. But yeah, there are times where we think it would work, but sometimes it just fail epically. Maybe borrowing the word that you mentioned. And many catastrophic mistakes actually happening as well, like deleting production database and things like that. So definitely there's something that I personally, even though I use AI a lot, I don't understand the fundamentals. Like I don't understand how all this LLM generative AI actually works. Maybe it's also a good time for us to understand a little bit about LLM, right?
Yeah, sure. So we need to, a language model, very simple computer program that tries to predict the next word based on the previous word. Very, very simple. And if you wanted to produce an entire sentence, you just make it eat its own output. So you generate one word or a token, should be a piece of a word, should be vocabulary. It just generates a piece of text. You add it to the prompt, then you run it through the program again, right? That's all it does. Anything else is a sort of illusion built on top. So for example, when AI seems to search the web, there's actually another program, a wrapper around the LLM, which intercepts an instruction that says, please go search the web. And then you go and you search the web with another computer program, and then you gather some results and you put them in your prompt, right? And then you continue. The user doesn't see this, right? But under the hood, it's just a system to predict the next word. And it was trained on two types of data. The first one is a huge amount of data collected from the internet. So if you want, this learns how to guess the best next word according to what internauts have said. There are lots of problems that have been solved by people. The solutions are online, and you can see that this can take you pretty far, but not completely far. The system will not going to learn how to do math, for example, because people are not saying online 2 + 4 = 6 with all possible numbers for the AI to actually get it. So what AI is going to do is going to create a plausible output, something that looks like a solution, but not an actual solution, because there's no data to support it. Same thing with the names of citations of legal cases. This lawyer uses ChatGPT to try to find legal precedents for a case, and it kind of invents names that sound good, but they're fake. And I've seen that a lot of times. So the second stage in training these AI models was to use manual data created by humans. So what they did was they asked people to generate lots of responses, and they ranked them manually. They said, this is a good response, this is a bad response. They did a lot of, trying to make it more appropriate, not say inappropriate things this way with people, paid very little money. Some people say they hired people in Kenya for $2 an hour to do a lot of this manual work. And then all this data was fed back into the machine. This is called reinforcement learning with human feedback to improve the models, make them more aligned, make them better at solving well-known problems, right? And that's how they're trying to fix the hallucinations on all these problems. But there's always like a long tail of problems that never disappears. But yeah, that's the essence of how. And another thing I want to say, why now? Why does, because the way this computer program works is different from what people were doing before when they created language models, which already existed. In the past, they were using something called an LSTM, which is a very naive type of technology, I think. I was always a bit skeptical of it because what it does is processes one word at a time, and it tries to kind of summarize the entire context up to now in one little vector of numbers that tries to express what's been said so far, which is a huge compression of all this information into a tiny little thing, and then you use that to predict the next word. But you've pretty much you've forgotten a lot of stuff. It's very, very hard. So what they invented was this so-called transformer architecture that takes the whole context and tries to represent the meaning of every token in the context simultaneously. They try to disambiguate the meaning of tokens by kind of cross-referencing them. And then it predicts the next word from a really, really rich representation of the context. And this is what changed from previous technologies. And this is something we've seen a lot in AI, which is that somebody invents a new approach. And that's when performance is unleashed. It happened with convolutional neural networks for image analysis, right? And now transformer architecture for text generation. Yeah, so kind of that's in a nutshell how AI works. Very simple principles, very powerful, but also not all powerful.
Right. And when people refer to generative AI, is it referring to the same thing as LLM, or is it something slightly different?
Well, that's complicated, first of all, because in academic circles, generative AI does not mean what people usually mean by generative AI. So forgetting about the technical statistical definition, just generative AI means AI to generate things. So it could be LLMs when we're talking about language, but it could be also images, right? And that's not an LLM necessarily, although you may be typing in something, or when you're transferring the style from an image to another, you could call it generative AI, but there's no language. When you're typing in, there is a language model somewhere in between, but you're generating an image. But what I would say is it's mostly about generating new content based on some cues or some prompts that we give to the machine.
Thank you for the clarification, right? So every time I read about the basics of LLM, right, the primitive understanding is that, yeah, it tries to predict something based on a given input, right? And you just multiply it with so many inputs, and maybe you train, you kind of like do reinforcement learning and all that. But somehow it just works magically. If you use some kind of assistant or maybe ChatGPT, they will say thinking, right? Thinking, and then gives you some explanation of what it tries to do, which if you read about it, seems very natural, like a human thinking and trying to deduce stuff. And even we use it for coding. Like I'm still amazed, kind of like how come it can produce code in a certain framework, in a certain language that mostly works syntactically correct and with a good output and things like that. Like maybe explain us a little bit. Like I'm still kind of like don't understand in between how come it can be so powerful and looks really smart.
I think that internally, those computer programs, right, the LLMs, they have states. They're called hidden states. We could think of a hidden state as a sort of abstraction that we don't necessarily understand what it is. We let the computer learn its own abstractions, right? So for example, the LLM may learn that to produce or to make good predictions about code, because that's what it's trying to do, it needs to have some sort of internal state that tries to produce syntactically correct code. As in, it will maybe count the number of opening parentheses, so that it matches the kind of the closing parentheses. So that's what makes it really powerful. There are many layers stacked on top of each other that have hidden states that try to, when the model is trained, these hidden states configure themselves, if you want, in the best possible way to solve the problem. And because there are so many layers of them, we can't really understand where they are if we will look, because it's gigantic, right? But I would say some people, they become a little too critical of AI, and this it's a stochastic parrot. It's just imitates or copy paste stuff from the data, the training data. Not really, right? What it does is it uses the training data to try to configure those internal hidden states. Initially, I remember asking ChatGPT, does an anaconda fit in a shopping mall, right? And it told me that it didn't because it's such a large animal, right? What this shows you that there was no hidden state that properly represented the size of things or what things are big or what big means, right? It was still producing good text in the sense that it sounded correct because its hidden states had properly represented the grammar of English, right? But not necessarily the sizes of things. But then this became quite viral, and as they improved the algorithms, they probably generated manual data. I have to believe that they did that probably somewhere, where people asking questions about the sizes of things and manually ranking the answers, and that was fed back to the LLM. And at some point, the LLM must have created an internal hidden state that tries to represent the things that are big in general, right? And when things fit into other things or stuff like that. We can't really know what it is because it could use shortcuts. There was a famous case of this image recognition algorithm or model that failed to detect a cow on the beach. And the reason was that the cow was not on grass. So the algorithm had actually learned that a cow is this thing that looks like a cow and the grass underneath, because all of the images in the training data had grass, right? So it didn't really learn what a cow was. So this also causes hallucinations, right? The AI may not really learn what we want from it. However, it does have hidden states that try to represent things with a higher level of abstraction, I would say. And because they're stacked on top of each other, it can combine them, right? So there's a first layer where it tries to represent some low-level things, right? Is this a noun? Is this a verb, right? At the next level, it could represent, is this a noun that represents a big object or a small object, right? And after lots and lots of layers, you get a very, very good representation of the meaning of things. And I think, yeah, the key to the power of this is all this hidden stuff that goes inside the machine.
So I understand, like, sometimes machine learning, you can't really explain what is happening because it goes through, I don't know, like thousands or maybe millions iterations. And that's why probably these hidden states are kind of like embedded inside the model, so to speak, right? And maybe now it's also a good time to understand about what is called a model. Like, people are calling foundational models, OpenAI, Gemini, Claude, whatever. I don't know how many foundational models are there. So maybe if you can explain, what is foundational model?
Okay, let's start with model. A model is essentially a computer program that tries to predict something. So it's the essence of this AI. There are different reasons for the use of the word model. You could say it's trying to model the world, but I'm a bit more practical with that. I don't like to use the word program because there are two programs in AI. One is the program that trains the other program. You have a program, right, which is this model, which an AI engineer will configure, but they'll leave holes in it, things that are undefined, that are called parameters, which are numbers, right? So you create a sort of template of the computer program, and then you need to run your training, which is how to scan all this data to try to fill in those blanks in the template. And that's another program. And if we use the word program, we get confused. So which one is which, right? So typically you will use the word model to represent the final result of your training, which is this program with all the blanks filled in, right? And then you use the word training algorithm or something like that to explain the program that actually does the training, right? So you have a computer program building another computer program. The last one is the model. And I think with foundational models, people mean very general purpose LLMs that can do lots of things, right? And they can be used as building blocks for other AI. So let's say you want to build an app that is based on AI. You may connect using an API to a foundational model, right? Or you may take the foundational model that is open source and fine-tune it to your own data so it works better on your specific problem, right? The foundational model would be very, very generic, and then you have your specific model to do what you want.
Right. So I think I'm always very fascinated by people who are producing this foundational model. I can't really imagine how they train it because it's such a general purpose. You can use it for language, you can use it for translation, math, whatever people want to try, right? I think it seems to be quite smart and powerful.
Mhm.
So these days there are new techniques that people are trying out, things like RAG and also agentic AI. So maybe if you can elaborate these also shortly, and maybe what other things that are new that probably we are not familiar with.
Yeah, RAG means retrieval augmented generation. It sounds very fancy, but it's not. It's essentially following. You have, let's say in your company, you have a database with a lot of your own private data, right? And you want to search, use AI to search or analyze that data. So what you do when the user queries something, they search for something, or they ask in a prompt for something, you run a separate algorithm to go and find relevant documents that could help. And then you insert the text of those documents in the prompt. The user doesn't see this, but you say, okay, these are the documents. So you need a large context window. You need a model that allows a lot of or very long prompts. You insert all this data and then you add instructions. You say, answer the original question referring to this data. What this lets you do is not change the foundational model, not fine tune it to your data, right? So it's a way to specialize an AI to your own company data or any specific data without changing the model. So yeah, that's RAG. And the challenge is, okay, how do we find that data? How do we find the relevant stuff? But a good application of that is what we see with Google AI results, which tend to be terrible, by the way. But anyway, we get to see AI using websites and analyzing websites. And the way it probably works under the hood is that first Google finds relevant websites using its old algorithms, and then it takes the text in those websites, puts it inside some prompt somewhere and says, answer this query using also this information, right? And then the LLM will generate answers, which are then intercepted and shown to the user. So that's RAG. And then agentic AI or AI agents. I feel like there's a new word every day coming up, and now agentic seems to be the new word. An AI agent means that there's an AI model that you use in a pretty autonomous way, and you execute some actions that come out of the model, probably in an automated way. So, for example, you create a little program that uses an LLM to generate some instruction, and then you use that instruction. You can imagine, I don't know, imagine an agent that scans your emails of a corporate person who travels a lot for business, and you tell the LLM whenever you detect that this person wants to travel somewhere, output this, because the agent can really do it. It's an output an instruction that says search for flight for these dates in this specific format. Then you connect that to an API that goes and searches for the flight, for example, right? And then you get the results and give them to the LLM, and you say, send an email to this person with a proposal of this could be your flight. So essentially, automate workflows and maybe even connecting multiple AI agents. But essentially, every agent is nothing but an LLM to which you send a fancy prompt.
Right. So I think when reading your book as well, right, explaining all these fundamentals, think about the AI LLM things that we understand now as like a cool thing, right? So definitely you can understand some holes that could probably poke you poke, right? And you can start seeing, oh, okay, why sometimes it hallucinates or it make mistakes, right? Simply because of the way it is, I don't know, the fundamentals of how it works, right? And maybe we can find clever ways of doing things like the rack and maybe the wrapper that you mentioned, right? Don't forget, I think the wrapper is also very, very powerful, I see, because, you can tweak the workflow, so to speak, within the way AI replies the response to you, right? I think the wrapper is kind of like the intelligence as well that people build on top of the foundational models. So I think thanks for highlighting all these fundamentals. So when people talk about AI these days, people think about I need to use AI. Businesses also scrambling so hard to implement, adopt AI. First, maybe adopt like ChatGPT and all that within their companies, and also building something smart, using AI. And I know in your book you mentioned, there are some failure modes that could happen. So maybe tell us how can business or organizations, start thinking about adopting AI or using AI within their companies.
Yeah. Well, there are a few things. The first one is that I don't think the best way to do anything is to have the hammer and search for nails, saying, what can we do with AI? I've met companies that created a whole team to promote the use of AI in the organization, and it didn't go well because they were very biased. For the survival of the team, they had to say this can be done with AI, right? And they didn't acknowledge the limitations of AI. In my experience, most AI or most failed AI projects start with that, saying, oh, what can we do with AI? So I wouldn't do it that way. It's good, however, to be aware of what AI can do, what the limitations are, because it's just another tool in the toolbox, right? So when you find a problem, something that could be done in a more efficient way in an organization, you can see if AI will fix it. I think the best way to use AI is to acknowledge these hallucinations from the get-go, or just the limitations in general of AI. Because if you embed that into your product, you can build a successful product. If you forget about that, you build a product that people won't like, because at one point they will be like, you told me this could do this job, but then it hallucinated, when I least expected it. So one way to recognize the mistakes, for example, is to have AI retrieve or point you to specific paragraphs of let's say, documents, and then show you so it's so much different when AI interprets stuff than when you use it to actually point you to something, for example, right? Because it can help people search for things more efficiently, right? And if AI gets it wrong, then you still very quickly you can see, okay, AI said this paragraph proves something, but it actually doesn't, so I'll keep searching. So I think we need to embed the idea that AI is not perfect in the way we use it, and that's how you succeed with AI. And another thing I think is, as a developer or in general, you want to use AI when you can describe your problem very succinctly. Because if you're doing something so difficult, so custom, that it takes you longer to describe it in the prompt than doing the job, you don't gain anything. So it needs to be something that's very generic, very easy to describe. And then it needs to be easy to validate, the output. A typical example is, you're coding and you already know how to do this, or you've done it before, but you forgot how to do it, right? So you would ask ChatGPT, how can I, read a file from S3 using this Boto3 library? And then very easy to describe. And then ChatGPT outputs a few lines of code which you've used before, but you'd forgotten how to. And you can also very quickly validate if it's working, so it's fine. Some problems are very difficult to describe, right? And in that case, I think AI is not necessarily going to save you time. And also sometimes the output is very difficult to validate, something you don't know at all, or a very complicated algorithm. And then you need to just read someone else's code, someone else being AI. And, you've read other people's code, and sometimes it's difficult to follow. So you need to make sure, to use AI in those easy to describe, easy to validate scenarios, I think.
Yeah, I think that's pretty good tips, right? Because I still think that companies try so hard to implement AI for smart products, right? So especially these days, almost every product embeds something called AI features inside it. It could be, summarizing something and things like that, right? But the most classical use case is actually chatbot, right? The conversational thing, because it has been around even before LLM, right? So I think a lot of chatbots, and now with LLM, I'm sure people are still trying hard to create chatbots, customer support thing. And we have seen many cases where, the agent responds something wrongly or incorrectly, sometimes even give, wrong result to the customer such that it misled them or the company, right? So I think definitely there's this risk of hallucination. How can companies deal with this hallucination? So is there something within their solution or within their implementation that they can do in order to reduce this hallucination from happening?
I mean, you can reduce hallucinations. There are techniques. You can improve your prompts. You can fine-tune your model if it's not working well with your own data. There's this whole thing called chain of thought, which is I tell the AI first, build a series of steps, a recipe to solve the problem, and then solve it, which some people say works better. That's what they mean by reasoning models. It's a whole charade. There's nothing really new there. It's more like using this chain of thought thing. But I would say you can really eliminate hallucinations, and they happen when you least expect them. So I would not use AI in the traditional way when hallucinations matter. Hallucinations don't matter in some contexts, right? If you're translating reviews of hotels on TripAdvisor, nobody cares if they're a little bit hallucinated, and they are. Sometimes the translation is not very good, but I just want to know if the hotel is clean, if it's well located. I don't need a perfect translation, right? But you can't have a hallucination in literary translation, right? And probably in customer service chatbots, you can't have hallucinations either. It happened to Air Canada that they, gave the wrong policy to a customer, and then Air Canada had to honor the policy because the judge told it to. It's like you can't just tell the client in a chatbot, yes, you can do this, we can get a refund for your flight, but then no, actually you can't, right? So that's not a thing. So if I were to work on this, I think I would use the chatbot as a way to let people find the information they need officially. So the chatbot can be a nicer way. It could try to interpret what people say and then point them to the right place, which is official data. And you should be very careful about not letting the chatbot, interpret results indirectly. Don't know exactly how you can do that, but I would frame it more in a way of how can I help you find information, right? That kind of thing. Another thing, like I feel like a lot of people are praising AI so much and the things that they can do, but it makes me wonder if they just weren't doing things very well in the first place, right? And it happens a lot with customer service. I used to work for a company, it was a travel company, and I understood the issue with customer service because I never contact, customer service unless something really odd happened. Otherwise, I just go and try to find the information that I need without having to contact anyone. But that's not how everyone does it. In this travel agency, people, they literally call to say, how much luggage can I bring with me on the plane? And this bombarded the customer service people. And the first thing you imagine is, I'm going to create a chatbot for this. But I was wondering, maybe the problem they had was communication. Maybe a few days before the trip, they should send an email to people telling them, hey, your flight is in 2 days. This is how much luggage you can bring. And maybe that will solve the issue, right? And I think there's a bit of, thinking AI can fix problems that you maybe could have fixed. Another thing that doesn't cease to amaze me is this whole thing of AI is so great for programming because it eliminates all this boilerplate code. And my question is, why do you have any boilerplate code in the first place? I don't have any in my work. I use libraries, frameworks to avoid, every time there's anything that seems like will be a bit repetitive, I already don't do it. I'm like, what library can I use where someone has done this, or how can I avoid this? I mean, some people, I've said this before, and some people told me, oh, but look at Django. Like when you use Django, you create a new view and you need to put the URL here, this there, and that there. And I'm like, it's literally 3 things. Is this what AI is really helping you with? Like, I still don't see why people have so much boilerplate repetition, right? So sometimes I wonder, is there anything deeper here that maybe you're not doing well and now AI lets you do it better, but maybe there was a different way before, right? At one point, I asked ChatGPT for an algorithm to calculate the position of the sun based on the time of the day and your location. And on repeated executions, it proposed different things. But one of them, it just provided a very long algorithm filled with numbers and trigonometry. And it had constants in it, like numbers. I was like, yeah, I could maybe copy paste this in my own code. I will never know if this works, if it makes sense. But there was a much easier solution, which was like pip install sun position calculator, which is the name of a library that does this, right? Again, I'd already done this, right? So I wasn't trying to get ChatGPT to do it for me. I was more like, I was curious to see what would happen. So then I kind of executed the query again, and ChatGPT did propose a library at another attempt instead of giving me the code. But it kind of hallucinated the way in which the library was used, how you called the function. So when I tried to run it, it didn't run, right? So it's like all this effort, when in reality, what you can do, every person who's coded for a while knows that there must be a Python library that calculates the sun position. This must exist because the ecosystem is huge. And people have validated this. It's a library that you can go and check the community. Are there lots of comments on the GitHub, a page And there were a few actually libraries that did the same position, but very quickly I was, okay, this one has a very nice interface to use, and there are it's an active community. So, in 5 minutes, it's running, right? So I don't mean to say that AI can't help you, because it can, but I also see a lot of that. Like, are we forgetting about good engineering principles? Are we forgetting about good customer service? Can we understand what the most common queries are, create a frequently asked question section, send emails to remind people of stuff? Because a lot of your problems can be fixed by targeting the underlying causes of the issue, not by using AI.
Yeah, I was laughing when you explained that, because I think it's such a quite insightful, right? So because people think just by applying AI can do smart things that can, solve all the problems, seemingly, right? But I think we know, like, it's probably not possible to cater 100%. And I was even frustrated sometimes if I get response from like seemingly an AI, right? That tries to even first re-explain what I just expressed as my complaint or problem, and then it gives like some basic information that I should have known in the first place, right? And then I have to wait again. So I think it's always very frustrating. But these days, people, when they build AI products, they seem to always rely on this thing called eval method or eval test to actually, kind of like train your solution such that it doesn't deviate so much probabilistically. So tell us about this approach. Is it something that is useful and people have to rely on, or is it something also that feels, like impossible to actually come up with 100% accurate solution?
I don't know exactly that approach, what it is, but I think I've been saying to people for a long time, you need to, whenever you're going to build an AI-based product, you need to create your own benchmark to measure the performance of AI at the task you're trying to solve. There's a whole process to do that that is a little bit more complicated than it seems, because you do need a validation set, which is separate from a test set. Your validation set, you use it to select among different models, among different options, to pick the best one. That's a little bit biased because you have selection bias, right? You could pick something that works really well only on that validation set. And that's why you need the test set at the end, where you perform an additional check, right? And you never go back. If you don't like the result of the test set, you need to collect a new test set with new data. A lot of people don't do this carefully enough. And, it's up to you to see how far you want to go to that process. But I've been telling people you do need a benchmark to start with. And then once you have your benchmark, you can see if a RAG approach works better, if a fine-tuning approach works better. You can compare different models. There's also something pretty catastrophic that happened a few weeks ago, which is that when OpenAI launched their GPT-5, is it 5? The latest one, yeah. They removed all the previous ones, right? And a lot of people were relying on previous models. So if you're forced into a new model, then you need the way of benchmarking to understand if the performance has changed on the problem you're solving. So yes, now this will tell you how good AI is for the job. It may not be good enough, or may be good enough. It will help you assess, the hallucinations. I would also be careful with just counting errors. You also may want to qualify them, because sometimes just by counting them, you don't realize how bad the errors can be and the impact they can have. People have been saying a surgeon that is 99% has a 99% survival rate versus an AI surgeon that has 99.5, which one would you pick and stuff? Okay, but does the AI surgeon cut the wrong leg sometimes, even if it doesn't do it very often? That's a kind of a question. But yeah, I think it's a good approach to do the benchmarking, to, try to understand, do hallucinations matter? Because they probably will still be there. Do errors matter? So do we still need a human into the loop? Do we not? Lots of things like that I would definitely. Is there another solution? Like I said, with customer service, can we do something else? What's the real problem? Another question is the problem I'm trying to solve a conversational problem? Is there language involved? Because I see people do this. They are building a travel planner where you actually input destinations from a box. You select them from a box, like not a box, like a drop down, right? Or a search box. And then what it does is suggest an itinerary in a very structured format. Under the hood, this company was trying to solve it by using an LLM. So they would take all the user's query, transform it into a natural language problem, give it to the LLM. Then the LLM returns something. You would have to parse that result to convert it into. And it was super slow for starters, right? It was really, really slow. And I told this company, nothing of this has anything to do with language. And the easier solution that they actually found was, we're just going to use a Google Places API, which just gives you, because it was an itinerary planning to visit a place, right? Or a city. So you can actually get up-to-date opening hours, which ChatGPT can do. So you just go and get them from Google Places, and you use a typical algorithm for like pathfinding, like Dijkstra's algorithm, which is, there are libraries for that. So they and that was really fast, and they solved the problem without any LLM. Right? So LLMs are best used when actually, for a chatbot, for instance, when it involves language. But a lot of people trying to use them for everything.
Yeah, I think that definitely it's kind of like people think it's a holy grail, right? And in fact, I think sometimes maybe because of the hypes, right? And people just creating new libraries, new tools, new stuff that works, that relies on LLM or maybe prompts, so to speak, right? They kind of like fit in, the solution with these prompt engineering kind of thing, right? Try to come up with the, as best prompt as possible, give as much context as possible. But you also mentioned, you highlight when the foundational model changed, definitely things probabilistically will change, maybe sometimes by a lot, maybe sometimes not by a lot. But still, you need to kind of like validate and test your approach, right? Because when this happens probabilistically, you might give a wrong output and suggestion as well. So I want to move on to the next section by, discussing about the concerns people have. One thing about AI, yeah, it creates a lot of possibility, but there are also a lot of concerns from people that, what will happen to my job? What will happen to my role? What will happen to, the world economy and all that? So maybe from the first discussion, I want to highlight the concerns, right? Especially for tech software engineers, think there are many, many software engineers that can be replaced, including juniors. So what is your opinion about this?
Yeah, well, I've written a lot about this in my second book on AI, which is called the AI Pocketbook, which we haven't spoken about yet. But part of the goal of that book was to answer these questions. I was approached by a publisher. They thought we need a book on surviving AI for software developers, right? And I was like, okay, I will definitely speak about the whole job market situation. I think there will be jobs that will be lost to AI for sure. Maybe prematurely sometimes, because we've already seen companies firing people and now hiring them back because it didn't work. So I think that, this could be we can speak about this from many angles, but from the angle of the person who wants to preserve their job, I would say that there are different kinds of jobs. Some jobs AI may be able to replace, and some it won't. So as a professional, you want to position yourself in that latter category, right? I think that there's a certain level of work that requires a lot of excellence. When you go above and beyond, when you rely on a network of other people, you need interactions, you need multiple skills. In the business world, that job is off. In the software world, it's often at the intersection between software and business. So you are not a person who takes a specification of a UI and codes that specification to the letter without an opinion, right? You are the person who will help the business choose the best feature to build. There are lots of positions that are like that. If you work for a startup, for example, you may need to be a jack of all trades, a person helping select features. As you progress in your career, you're closer to the business very often. So my advice is often try to work at the intersection between business and technology. See yourself as a person who helps build commercially successful products, not just write software. Because I think you will be quite irreplaceable when you're that person. And another thing I think is that a lot of people speak about other people's jobs. They say these people will lose their job, but they've never met a person who does that job, and they don't know what it takes to do the job, right? Especially at the excellent level, right? I've seen this a lot. People say screenwriters will get replaced with AI or replaced by AI. But then have they met a screenwriter? Have they seen what it actually takes to produce a show that people love, that people laugh at or laugh with? I'm listening to this podcast called Office Ladies, which is by the actresses from The Office, where they tell you stories behind the show. And you can see how much thinking there was sometimes about certain storylines, that they decided to include in the show. There's so much that goes on, and writing a show. Yes, there are some cookie cutter show, soap opera kind of show that maybe AI can do. But there's so much more that happens when people are writing a show. And the same thing with programming, with code. I feel like maybe I'm also a bit more senior in my career, but most of my work in software is not writing code in terms of, I'm going to move this button from here to there. There's a lot of thinking about security, about architecture. A lot of this has to do with negotiating with business. A lot of it, the business wants to do this, but this is really big and they don't know it. So I explain to them why it's big. And then I propose a different solution. What if we do this other thing? It's not as great, but we can do it quickly. And then we can see how people react. And then we see if we build the bigger thing that you want. All of this help, is part of software development, but it's not writing lines of code. So if I had to recommend to a software developer, again, I would say a lot of interaction with business, a lot of high-level work business, learn about business, read business books. Because a lot of us, we have no idea about anything related to business, to sales, to value propositions, how to define a value proposition, for example. There's a book called Value Proposition Design, which I recommend. So yeah, I think that a good way to protect that your job is that, Yeah.
Yeah, so I think that's very good advice, right? Because obviously, when we talk about AI replacing jobs, is probably the first will be the mundane things, like producing lines of code, translating from, one thing to another, or even like maybe when you say about screenwriter, maybe not necessarily screenwriter, but someone who polish, some writings some drafts that people do, right? So those kind of things, definitely the first prospect that could be replaced, right? But if we keep moving to the higher level, like when we talk about programming language, also the same, right? It started with like machine language, then becomes general programming language. Now you have conversational language. If we can think of ourselves moving to the higher abstraction, maybe, so to speak, maybe we can even amplify, the value that we can produce, right? So I think I agree what you said, that software engineers need to understand more about business, or maybe thinking in terms of, how can we make this more successful, commercial, some psychological aspect, human aspect that probably software engineers can also explore. So how about the juniors here? Because I think the juniors might be kind of like frustrated, right? So I just finished my study, for example, but now I'm finding it hard to find a job. So do you have any advice for them?
I mean, I spoke about this excellence side of things, but there are other things that will be helpful. One of them is when you work on very customized work, if you want, that is very kind of complicated and narrowly specified and stuff. If you work on complicated stuff, and I can give you a couple of examples, those things are unlikely to be replaced by AI because, first of all, you can't even describe to an AI what you need to do. Even the business people will not understand. And I can give you an example. I worked on a project that involved modeling the propagation of temperature or of heat inside a building, right? And I was writing the software for this, right? All these complicated calculations, but it was so custom, and there were devices connected to buildings using APIs where we get the data, and then physical models, and there were parameters that define, the insulation of the building. It's very hard for me to even imagine how you could describe all of that in a prompt, which is not the same as writing the code, essentially, right? So I would say you want to specialize or to gain experience on tightly controlled kind of software. An example of what's not like that is, building a prototype just to show something to a potential client, but it doesn't really work. There's a lot of MVP or no code kind of thing going on there. It's like, we're going to build not a really functional thing that works with lots of clients, with lots of custom requirements. We're just going to build a very rough prototype to validate an idea, right? I think those are the jobs where people are going to be replacing that with AI a lot. But then you can do very, very custom, kind of like focus on really tightly defined, custom, complicated problems. If they can be a bit scientific or they require mathematics, it's likely business people will not have studied those things either. So they won't be able to know where to start with those problems. Also, working on anything that is mission critical will help you. When I say mission critical, something that you deploy a piece of software that could lose a company a lot of money if it wasn't used correctly, or it could even cause harm to people, because this is going to require a lot of manual validation, of manual input, of, I don't think that's going to be replaced by AI anytime soon. So if you can become the person who learns about those things, then it would be a better place to find a job or to preserve your job.
So I hope people could learn from these tips. So when you mentioned about building prototypes, right, my mind straightly go to vibe coding, right? I think many people think, now everyone can code, just doing vibe coding. And even it might be creating a perception that you can be a vibe coder. There might be a job role as a vibe coder, specializing in vibe coder. Same thing like prompt engineering, I can be a prompt engineer that can solve, maybe general purpose AI conversational kind of a thing. So maybe tell us your view about this, and will in the future we see new job types being created, something like this, or is it more like a hype now?
No, I think there is a place for everything, and there is a place for a job title that is a vibe coder, potentially. Because we've seen that with Bubble, Bubble, the no-code tool. I've seen people who specialize, because you need to actually learn how to use those tools at the end of the day, especially if you want to build something custom, which is kind of part of the problem here, is that if you just type a little prompt and you accept what comes out of it, then it's fine. But if you want to start, like with no code, you often need to learn what a platform does and how to use it, how to connect it to data sources and all of that. And I've seen people who specialize in helping companies build with Bubble, right? Because it's cheaper, it's quicker, right? You're not going to build production grade software. That's the illusion that we need to kind of eliminate. And whenever you want something really custom, it's as difficult as coding, because coding is that. It's literally telling the machine what you want it to do, right? So the illusion that that's the same as building production grade serious software, I think that illusion needs to go. But there's definitely room for that other thing in between, where you help with MVPs, where you help with prototypes, right? We could see UI designers maybe using AI to create better prototypes for their clients, which are more functional than before. So there will be changes definitely in there, and there will be new jobs and new opportunities, I think. Yeah.
Yeah, so hopefully as with a new, I don't know, technological disruption, I think there will be a lot of fears in the very beginning, but hopefully after that we kind of like thrive, and maybe in the new opportunities people move on to new kind of skill set and solving bigger problems and things like that. So hopefully that will be the case. And speaking about that, right, so I want to touch on this one thing that I think is worth to discuss shortly, right? So the AGI possibility. So I think many AI companies think AGI will happen, I don't know, 3 years, 5 years, whatever that is. Sometimes I listen to podcasts as well. There are seemingly AI experts telling that humanity is in crisis. So personally, do you think AGI will happen, or maybe some resemblance of it? So yeah, maybe a little bit on this part.
Look, the first thing, okay, AGI, artificial general intelligence, right? A computer that can do anything a human can do. It's not very well defined, but we're talking about really super powerful AI. Well, the first thing I want to say, it sells so much to make those predictions. There's nothing that sells more. People have built entire careers around predicting that. An example is Ray Kurzweil, who's written these books on the singularity, saying the singularity is going to happen. Singularity is when the machines become so smart that they can improve themselves at an exponential rate and everything collapses, and it's like a sci-fi world. People are fascinated by that, and it sells so much. I feel like people who speak the way I speak about AI, and I've heard the same experience, from other people, we actually struggle more to be heard because people don't invite you to give talks as much. Who do you want on the stage? There's a reasonable person telling you AI is smart, but it's also kind of dumb. Or do you want a person telling you how it's going to be the Terminator? And it seems like the latter it sells a lot. And when I was looking for a publisher for my first book on AI, I remember I spoke with an agent that he's a pretty prominent agent, like a book agent. And he told me, no, like your book won't sell because you have to either say that AI will be so amazing that it will change everything, or it will destroy everything. If you say something kind of in the middle, nobody really likes that. The first thing is like this AGI thing is, and it's also self-serving because a lot of people are making money from selling the shovels or selling the AI to build AI or AI for this, and then they tell you AGI is coming, right? I would tell you the answer is no. So AGI is not coming anytime soon. And the reason is that the current methodology used to build AI, which is machine learning, has some flaws. And these flaws cause the hallucinations, for example, which will prevent AGI, right? They are not solvable right now within the methodology that we know. This means that if a new methodology, something different from the current type of machine learning were invented, maybe it could be solved. I don't know. There's also a question that in principle this is possible or not. But even if we put that aside, if a new methodology is discovered, maybe. But nobody knows that methodology now, right? We don't know it. And we need to acknowledge that we don't know it. When GPT-5 came out, and it was a flop, a big flop and a big disaster, because it was nothing new. It was maybe a little bit better, but not really. I wasn't surprised because nobody has discovered that secret ingredient, or if you want, that new methodology to solve hallucinations and stuff. So to me, it was no surprise that GPT-5 still hallucinated because they haven't discovered anything that I know of in between, right? And you can't predict scientific discoveries like that. The transformer architecture was the discovery that led to LLMs, or like to the current powerful LLMs. What's the next discovery? We don't know. We don't know when it's going to happen. I always cite the example of nuclear fusion-based power. They've been telling us for decades that that's the future. It's around the corner. The problem is that the methodology hasn't been found, hasn't been discovered to do that. And they can keep putting money into it, and maybe that will help, but we don't know if it's going to happen or when, right? And that's the situation with AGI, right? I feel like a lot of the philosophical questions around AGI, they're valid and it's good to ask them. What would happen? Like, what happens legally? Does a robot have feelings? I like those questions. I think they're fascinating, but they are not the reality of current machine learning. Like this thing of, I'm going to learn from data how to predict the next word. It's not going to lead us there, and it's going to keep hallucinating. But then if a new thing is discovered, maybe.
Right. Pretty exciting answer, right? So I think people sometimes, I don't know, sometimes, they project something that seemingly bombastic and then, it sells like what you mentioned, right? But we have seen it with the ChatGPT 5 release, right? So it kind of like flopped a little bit. So maybe, the AI hub is not as great as people sold it to be, right? But obviously these next few years will be very, very exciting, unpredictable at times, right? Because there will always be new things being invented and we just have to adapt. I guess my stance now, even now, is just, see, adapt, use them as much as possible, understand what it's capable of and not capable of, which is also very, very important, and try to fit in yourself, your skill set, your value into those landscape, right? So I think probably that's like the most practical thing. So Emmanuel, thank you so much for this conversation. So I know we are a little bit over time, but I have one last question that I have to ask you. This is like a tradition in my podcast. I call this the 3 technical leadership wisdom. So if you think of them just like advice, would you be able to share your version today?
Yeah. So I would say, look, the first one is that there's a term called a moat, as an MOAT, right? Like a protective moat. It's also called a competitive advantage. I think a lot of people don't understand much what this means, or they've read some books that tell them this is a competitive advantage when it's actually not. I think there's a lot of confusion around competitive advantage, and I've been doing a lot of research myself on the matter. What I mean with all this is that you need to understand that building a successful business is a business problem. It's not a technology problem. It's usually, no business has failed because you use Python 3.5 instead of whatever. And the role of a business person, or even the goal of a business, is, even if we don't like it, is to create a sort of monopoly. You want a moat that protects your business from competitors. You need access to a special way to keep your clients, or to gain more clients, or to access resources cheaper than anyone else. There needs to be a special thing, and that thing is called a moat. And one of the reasons I tell you that I think technology leaders need to keep this in mind is that there are a few ideas going around that are terrible. One of them is this 10x thing. You build technology that is 10x better than other technology, and then you're done. Your business is, that's not true. And the proof is that ChatGPT was definitely, I think, a 10x kind of thing. And the business is doing terribly. They're losing billions every year. And the problem is they have no moat. There's nothing special. Having a specific type of technology doesn't build a moat around your business. What is aggravating here is that everybody knows how ChatGPT works, right? Because it wasn't even invented by OpenAI. It was invented by Google researchers who published the work on a scientific paper. And I've been saying this to people, right, a lot. And I kind of predicted this. I wrote a book called Silicon, also, where I wrote about this, about OpenAI and stuff. And then what happened now is DeepSeek comes out. And then the world is like, oh my God, it works as good as, OpenAI's models. And what's this going to mean? Yeah, we knew this was going to happen because there's so much money to be made, probably, in AI, that a lot of other entrants, competitors, copycats, are going to try to build the same thing. So you do not actually build a successful business around having superior technology. You build them around, for example, network effects that keep people engaged, or you build them around switching costs. People don't want to leave you because they're kind of stuck. With Apple, you have all the Apple ecosystem, so you don't want to switch to a different kind of phone. Those are the things that actually make or break a business. It's not the technology. Another thing that I think is very prominent in the technology world is a surge cost. Not a switching cost, a surge cost, meaning that you want to capitalize on the fact that people will find it annoying or costly to search for an alternative. I think Canva benefits from that, right? People don't want to use anything else because they know Canva, and they're not going to start searching for Canva, and they don't even have opportunities to find alternatives. Whenever they want to do any simple graphic design, they just go to canva.com. But again, why I'm telling you this, because the key to the success of this business is that the product is cheap, right? If Canva tries to charge a lot of money, this search cost starts to not protect the business anymore, because people are going to start shopping around. They're going to go, oh, Canva is now $200 a month. Can I use something else? And business strategy is about this. And I think a lot of technologists like me, I didn't learn any of this in university. I learned how to code. I learned how to create really fancy SQL statements. But that doesn't make or break a business. It's the business side of things. And the competitive advantage is super, super important. So that would be my first, I don't know what you call it, my leadership something. Second one, there's a lot of boring stuff to be done. The most successful entrepreneurs I've met have built something really boring to help a boring industry do something that was super inefficient, right? And speaking of competitive advantage, I think the moat that they had was that it was such a niche thing that it's actually a small market, and people don't want to enter the market once you're there. Your clients have switching costs that are really high. And I've seen this a lot. I've seen it in aviation a lot. A lot of stuff is done on paper nowadays. People literally, they fill in paper forms even today to track the maintenance of an aircraft or stuff like that. There's so much stuff that's done badly. And I think there's a lot to do in the world and in that kind of boring arena. But it's not flashy, like building the new goggles to pilot your drone or whatever. And, and it's like, but actually it's a lot of fun to work on things that people actually use and care about. There was a person who recently quit a job at a very fancy startup and joined another company that is, I can't name it by name, but it's a company you've heard of, and it's a company that builds software that is actually very useful. And I think it benefits from the sort of Canva effect that people just go and use it because it's cheap. They're not going to shop for alternatives. It's doing really well. And she was telling me that she was a bit concerned. She was like, oh my God, I'm going from this alleged unicorn, which is never happening. The company has never actually turned into a unicorn. The stock options are worthless. And then she goes into this business, but it's actually been very exciting for her to work on a product that people use, even if it's not sexy, because this is not a sexy product. So don't forget about the boring stuff. So that would be my second thing. And then the third one, which I already said, but I think I would like to go back to that, is that if you're building anything based on AI, you should acknowledge the limitations of AI from the very beginning and embed them in the product. And that's how you're going to build a successful product, right? If AI hallucinates, maybe do something so that, again, you quote a passage from the text. You do not interpret it. You don't leave room for hallucinations. I've spoken to companies that are doing a good job in this sense, right? They're building an AI-based product that generally helps save time for people without pretending that it can do the job in a flawless way. And people are liking the product, right? And I think that's something you need to consider. Yeah. So those are my three.
Wow. So I find it really insightful and very beautifully said as well. So the boring stuff, I think I like it the most, right? Because sometimes we are so much into the hype, right? So we chase all these hypes, but definitely there are things that are still working. Maybe it's boring, but it's useful and people use and it creates value in the world. So I think thanks for reminding us those things. So Emmanuel, if people like this conversation, they want to reach out to you, ask you more questions or discuss about, AI stuff, is there a place where they can find you online?
The best place is LinkedIn. I usually post stuff on LinkedIn. That's where I hang out. I know it's a little bit weird. Some people will tell me, why are you on LinkedIn and not on Twitter? But that's the main place for me to communicate with people. And you can also find my books to learn more about the things I have to say, and you can send me a message on LinkedIn. Yeah.
Right. So I highly suggest people reading your book, especially if you want to demystify the AI hypes that is happening now, like try to understand the power of it, the fundamentals of it, and the pitfalls where AI might fail. So thank you so much for writing those books, Emmanuel, and for this conversation. So I hope you enjoy this conversation, and thank you again.
Thank you.